Which one you want? Give me the question which you want.
Anyone, sir.
Anyone is okay. Convert SR
Yes, sir.
into D flip-flop. So here the first step is we need to write the excitation table. Write the excitation table of the SR flip-flop. Here the first one indicates this is a given flip-flop. We want to make this SR into D. Conversion of one into another. And the second step will be we need to take the characteristic table of the flip-flop which we need.
Okay, sir.
Okay, so tell me the excitation table of SR. You need to remember this or else you can't. Relation between
Q and Q plus
Q
1.
and plus 1 S R.
so Qn
SR.
plus 1 S and R.
4.
What are the outputs? Correct.
Yes, sir.
Excitation table of
Yes,
SR
sir.
flip-flop is done. Next, what is characteristic table? What is characteristic table? It gives relationship between
Q and D.
Qn
Qn and
D
D.
and
Output
it will
is
be
Qn
Qn plus 1.
1.
So two variables are there, 4 combinations 0 0 0 1 1 0 1 1. And tell me the outputs for D
0 1
flip-flop.
0 1.
Okay, it will be 0 1 0 1. Why? Because Qn plus 1 is equal to D. This is called as
D.
what?
Characteristic equation.
Characteristic equation.
This is called as characteristic equation. Next. So here you need to take as S and R. Now what you have to do is simply compare the Qn plus 1 values from the excitation table and write here. So compare the values for 0 0. See here for 0 0. What is the value?
Don't care.
Write as 0. Don't care. Next for 0 1. Check
1
from this
0.
table. Okay, it is 1 0. Next for 1 0.
0 1.
It will be 0 1. Next for last combination 1 1.
Don't care 0.
For 1 1 it is don't care and 0. So
K
after
map
this
for S
K
and
map for S and R. How many variable K map?
4 variable K. So 2 variable K map.
2 variable K map. Inputs are Qn
Q
and
and D.
Qn and D. So here 0 1 0 x. So write as 0 1 0 x.
1
This
pair.
is for S.
1 pair.
S equal to D.
So answer is S is equal to D. Okay. Tell me for the next one. It is
Don't
x
care.
0
Equal to
1
D
0.
bar. Sorry, R equal to D bar.
Qn.
1 pair.
D bar.
So one pair is possible, which is
D bar.
D bar. Now, which is a given flip-flop in this? SR or D?
SR.
SR to D.
So you are having SR flip-flop. Now you want to convert that SR into D. So first draw the SR flip-flop. So inputs are S and R and outputs are Q and Q bar. Or else if you are taking as Qn, better write as Qn only. Don't get confused here. Both are correct. Qn, Qn bar. Let me take as Qn and Qn bar. Now tell me the answers which you got. What is the answer for S?
D bar. Sorry,
D.
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 For S it
D
is
bar.
D and R is D bar.
D bar.
R is equal to D bar. So connect an external input which is nothing but D and complement of D is nothing but D bar. Apply it to the R. Apply some clock here. Over. This is how we are converting SR flip-flop into D flip-flop. So by adding these external inputs, now this particular SR flip-flop will function as D flip-flop.
D flip-flop.
Concept will be same for all, but the important thing is you need to remember the excitation tables, characteristic tables, and truth tables of all the flip-flops.
Okay,
Are you all
sir. Thank
perfect
you.
with excitation tables, or else do you want me to write here once again?
No,
Once
sir.
you write it.
Once, okay. Tell me the excitation tables. First, tell me the excitation table of SR. It gives relationship between Qn plus 1 and SR.
Qn plus 1 S and R.
So two unknowns, so 0, 0, 0, 1, 1, 0
0,
and 1,
0,
1.
it is 0, don't care.
Better try to
0,
remember
1,
like this. 0, 1,
0,
0, X.
don't.
And again, reverse direction. X0,
reverse.
1, 0.
1,
1.
Next, tell me for D flip flop.
0, 1, 0, 1.
Okay, 0, 0, 0, 1, 1, 0, 1, 1. It will be 0, 1, 0, 1. Why? Because Qn plus 1 is equal to D. Next, third one. Tell me for JK.
Don't care, 1, 0.
It is 0, 1, double X. Next, double X, 1, 0. Correct?
Yes, sir.
Next, tell me for the last one, T flip flop.
0, 1, 1, 0.
It is 0, 1, 1, 0. So better try to remember this one or else you can't attempt flip flop conversions. Next, characteristic tables of SR. Tell me the characteristic table of SR flip flop. It gives relationship between Qn,
Qn
SR and Qn plus 1. SR.
Qn plus 1. So 3 unknowns, 8 combinations. How will you write? In order to write characteristic table, it depends on.
Truth table.
Truth table.
So characteristic table depends upon truth table. So if you observe truth table, it will be like this: Qn 0, 1, X for SR flip flop. So what is the value of Qn here?
0.
So first it will be 0. Next it will be by default 0, 1, don't care only. So 0, 1, don't care. Next here it depends upon Qn. What is the value of Qn?
1.
It is 1. Again 0, 1, don't care.
Don't.
If you do the K-map for this, you'll get characteristic equation. What is the characteristic equation? Qn plus 1 is equal to S plus Qn R bar. Okay, in short, he may ask you to write all the characteristic equations for 2 marks. So be prepared for this one also. Next, characteristic equation of tell me.
K-maps very fast for 2 marks.
You have to do the K-map, but better to remember the answers. Instead of wasting the time, remember the answer, draw the K-map and write the answer. Next, tell me for D flip flop.
Qn, D and Qn plus 1.
Qn plus 1. So here 0, 0, 0, 1, 1, 0 and 1, 1. So you know already here this is 0, 1, 0, 1.
0, 1, 0.
So do the K-map.
1 equal to D.
Qn plus 1 is equal to D. Next, characteristic table for JK.
Qn,
Relationship between
Qn plus 1.
Qn, JK, Qn plus 1.
8
What will be the difference here? So what is the truth table of JK? Qn 0, 1 and don't care or Qn bar?
Qn bar.
Qn bar.
This is the only difference. If it is SR flip flop for the truth table, it will be Qn 0, 1 and X.
0, 1 and don't care.
So now to overcome this one, we have given some feedback. So we are getting Qn bar. Now tell me, how will you write? What is the answer?
0.
Qn value is 0. Okay, correct. Next.
Last 0, 0, 1.
0, 1.
1.
This is Qn bar.
1.
Okay, 1. Next.
1.
Okay, Qn. Next.
0, 1,
Okay.
0.
1, 0.
So simply take the complement of this one here. And if you do the K-map, you will get the characteristic equation. What is the answer? Qn plus 1 is equal to J Qn bar plus K bar Qn. This is the characteristic equation of JK. Next, characteristic table of T flip flop. Qn T and Qn plus 1. How will you write this one now?
0 1 1 0.
How you are writing? What is the truth table of T flip-flop?
All memories, last one will be racing condition.
0 double 1 0.
It will be something like this. For T is equal to 0, you'll get output as Qn. For T is equal to 1, it will be Qn bar. So
Qn.
based on that one only I wrote here. For T is equal to 0, it is Qn. So Qn is 0, so write 0. For T is equal to 1, it is Qn bar. So here Qn value is 0, take the complement. So this one will be 1. Next, again T is equal to 0, this is 1. And the last one will be 0. Why? Because for T is equal to 1, you have to take the complement of Qn, which is nothing but 0. So 0 1 1 0 is the characteristic table. And tell me the equation. Qn plus 1 is equal to T Qn bar
T bar.
plus T bar Qn. How I am writing this directly?
T XOR Qn.
How I am writing directly without
Sir,
doing K-mux?
0 1 means Qn bar into T. 1 0 means Qn into T bar. We have to add them.
So directly you can write like this by seeing the ones. 0 means Qn bar and 1 is nothing but T. Similarly here Qn T bar.
Qn into T bar.
So first you need to remember all these tables so that flip-flop conversions will be easy. Done. Next, what are the doubts in unit number 2? Multiplexers you want. You are perfect with adders? Better let us do the multiplexers. What is multiplexer?
N inputs and single output.
N inputs and single output.
The multiplexer means it contains n inputs and single output, and anything is present externally. And how many types of muxes are there? Let us do 2:1. So what is this 2 and what is this 1? What is 2?
2 is input.
2
Sir.
is input, 1 is output.
1 is output. So it is a 2:1 multiplexer which contains 2 inputs and 1 output. So I'm taking this as I0, this as I1, and output I'm representing with Y. Internally you need to write as 0 and 1. Okay, done. Anything else? For multiplexer, any external signal we need to give?
Yes, sir.
What should I give externally?
S1.
What is
S1.
that S?
Selection.
Line.
Selection line. Without this, your multiplexer will not work. So how many selection lines should I take? So
1.
inputs are 2. How will you represent 2? 2 power 0 or 2 power 1?
2 power
2
1.
power 1.
2 power 1. Here this 1 indicates the selection line. So take only one selection line. Okay. Now tell me for 4:1. 4:1 multiplexer contains how many inputs and how many outputs?
2 selection
4
lines.
inputs.
4
It contains
inputs,
4 inputs,
1
1
output,
output.
and 2 selection
and
lines.
2 selection lines.
Why? Because 4 can be represented as 2 power 2. This 2
power
indicates
2.
selection
2
lines.
square.
S1, S0. This is your wish. You can take any name here like D0, D1, anything you can take. I0, I1, I2 and I3 I'm taking. And internally 0, 1, 2 and 3 and output will be Y. So first this is a basic diagram you need to draw. Now tell me the working of this. Single variable can have how many combinations? S
2.
can have?
2.
Okay, it
2
can have 0 or 1. First if I apply S is equal to 0, what will be the output?
I not, sir.
So if you apply S is equal to 0, this will be connected to the output. So you'll get output as I0.
Y equal to I.
Next, if you apply S is equal to 1. If I apply S is
I1.
equal to 1,
I1.
so at 1 if you
I1.
are applying anything, you are connecting it as the output. So you'll get output as I1.
I1.
So what is the conclusion? If S is equal to 0, I am getting Y is equal to I0.
I0.
If S is equal to 1, output is?
I1.
I1.
So finally try to add them. So 0. So always we will follow SOP only. 0 is nothing but bar or normal.
Bar.
0 is bar, 1 is normal.
Normal.
So S is equal to 0. So write it as S bar. So when S is equal to 0, I0 is the
I
output.
not
Next,
into I1.
S into
I1.
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 This is
I1.
nothing but Y. Done.
Sir,
Or
if we
else you
write
can,
in this way, it is enough, or we have to do truth tables, sir?
you better see the number of marks. Suppose if it is getting for 2 marks, so this much will be more than enough. But actually, in order to make you understand the concept, I have told you the truth table. Better try to write the truth table only. That would be better. And by solving the K-map also, try to elaborate. Just now as Sanjana wrote everything in detail, so in that manner only you need to write in exam. Just for cross verification, I have told you all these shortcuts. Now tell me this one. Now tell me the output expression for this. When
S1
S1 is equal, when both are zeros, what is the output?
0.
A.
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 A will be the output. Next, for 0, 1,
B. B.
this one will be B.
For 1, 0.
So 0, 0, 0, 1, next it is 1, 0. For 1, 0, output will be
3.
C.
for 1, 1 case, output is D. Now tell me the final
D.
expression.
S1 bar, S not
S1
bar,
bar S not
A.
bar A plus S1 bar
S1 bar,
not
S not
S1
B
bar
plus
S
S1
not
S not bar E plus S1
S1
S
S
not
not bar
plus S1 S not into D.
So this is the Boolean expression for 4:1 multiplexer.
Sir, once you explain truth table for this, sir.
You want truth table in detail. Okay, so better see in that manner. I think you all are perfect with all the added, subtracted, and Verilog codes also. So this question
Yes.
is mandatory. This one will come for sure. Full adder by using 2 half adders. Two is to one multiplexer. So this is a block diagram which contains 2 inputs and 1 outputs and 1 selection line. Just now we have seen this one. And suppose if you want to write in detail the truth table, so how many inputs are there for 2 is to one multiplexer?
2 inputs.
3.
You have to consider
3
S as
inputs.
two
also the
inputs and one selection line.
right. 2 inputs and 1 selection lines. So total it will be 3. So if 3 unknowns are there, you'll get 8 different combinations. So right from 0, 1, so until 7. Now, in order to write the outputs also, you need to remember this table, the one which we wrote as a shortcut just now. When S is equal to 0, what will be the output?
I
I
not.
not.
As
When
I
S
not
is
is
equal to 0,
0,
output will be I naught. When S is equal to 1, output will be I1.
I1.
I
So here output should be I naught. Here also if S is equal to 0, I naught should be the output. So that's why you'll see output as 0, 0, 1, 1. See here 0, 0, 1, 1. Next, if S is equal to 1. So in this 4 cases S is equal to 1. If S is equal to 1, output should be I1. So what you are applying at
I
I1, you're applying. So these are
zero
the
one
inputs.
zero one.
So you'll get output as 0, 1, 0, 1. Now after this, take the K-map. And how many variable K-map you have to take?
3 variable came up.
Three
So
Variable.
take
variable.
3 variable K-map. Inputs are nothing but S, I0 and I1. In this order only you need to write. And what is gray code? What is
Difference
gray?
should be for only 1 bit. 1
Only
bit
1 bit.
difference.
So it is also called as unit distance code. Now, what are the minterms for this? For this particular table, what are the minterms?
2, 3,
2, 3.
7, 5, 5, 7.
2, 3, 5, 7. So here this is 0, 1, 2, 3, 4, 5, 6, 7. So 2, 3, 5, 7. How many quads, how many octets, and how many pairs?
2 pairs.
2
Two
pairs.
pairs.
Only 2 pairs are possible. What is the answer for this?
S not, I not. S bar, I not.
Okay,
SI1,
here
sir.
this
S,
is S,
I1.
I1. So
SI1.
finally output will be S bar I naught plus SI1. But in exam you try to elaborate this one also in detail. Like you have to write like this. So 0 S bar I0 I1 plus S bar I naught 1 bar, like
I1.
this you write, and after that you try to minimize and get the final answer. Map and the logic diagram is a must for everything. Based upon your answer you need to write y is equal to S bar I naught plus Si1. Someone are still having the confusion in drawing the logic diagram. So how many AND gates are there here?
2.
2.
2.
Two AND
3.
gates.
3.
How many OR gates? Three AND gates.
2 only, sir.
No, sir.
2
No, sir.
only, sir.
Two AND gates. OR gates.
1.
One OR gate. How many NOT gates?
1 not.
1.
1.
One NOT gate. So total 2, 3, 4. Overall 4 basic gates should be there. So for the first AND gate, inputs are S bar I naught.
S bar
So
and I
S,
know.
after passing through the NOT gate, it becomes S bar applied to the AND gate, and another input is I naught. Next S I1. So one input is S. I'm taking S from here and applying some external input which is I1. So this is S I1. So S into I1 will be the output. Here it will be S bar I naught. Finally try to add them by means of an OR gate. This will be the final logic diagram. And familiar with Verilog code, or else any doubt still? So based upon the logic diagram and the notation that you are writing, in that manner only you
Sir.
write the Verilog code. Yes.
Sir,
Sir,
de-multiplexer, sir.
Sir, implementing full adder using half adder, sir.
Implementing full adder by using half adders. Okay, without seeing better we shall draw. So first tell me what is half adder? What is the truth table? What is the K map? And how many outputs will be there?
2 outputs, sum and carry.
So two inputs are A and B, and outputs are nothing but sum and carry, or else write carry and sum, anything is okay. So if two unknowns are there, we'll get four different combinations, that is 0, 0, 0, 1, 1, 0, and 1, 1. So here try to add them. So 0 plus 0. So 0 plus 0 is how much?
0.
0.
So the 0 should I consider as sum or carry?
Sum, sir.
Sum. So there is nothing present, so carry will be 0.
0.
Next for 0, 1 you tell me.
For 0, 1 is 1. 1 means
1.
sum.
1 is sum.
0 is
0
carry.
is carry. Next 1, 0.
Sum is 1, carries
Next
0.
for 1 plus 1.
1 plus 1 is
And
2.
2 is
Equivalent
represented
of
as
2 is
1, 0.
1, 0. 0 is sum, 1 is
Sum
carry.
and 1 is carry.
So 0 plus 0 is 0, 0. 0 plus 1 is someone carry 0. And here also someone carry 0. And here carry will be 1, sum will be 0.
1, 0.
Okay, next do the K map for sum and carry. So what are the minterms for sum?
2 and 1 and 2.
1 and 2. Carry
3, sir.
3.
3. Do the K map. Inputs are A and B. So minterms for sum are 1 and 2. So 0, this is 1, this is 2. And for carry it is 3. So in this place it will be 1. Inputs are A and B. This is 0, 1, 0, 1. So pairing is not possible. So singles will be
2
there.
singles.
So if you write answer will be
A,
A,
B
B
bar
bar,
plus A bar B.
A bar
A
B.
A
XOR
Carry,
XOR B.
carry is
A
equal to A dot B.
B.
Done. So these are the Boolean expressions which we got for sum and carry. Now by seeing this, try to draw the logic diagram. So how many gates should I use?
1 XOR and 1 AND gate.
1 AND gate.
So take one XOR gate and one AND gate. Inputs for XOR will be A and B.
A and
Here
B.
also A and B only. Output is sum. This one
Carry.
is carry. This is a logic diagram of half adder.
Half adder.
Now full adder, you tell me. Inputs are A, B,
C
carry
in
input.
carry and
Outputs are
Carry and sum.
carry and sum. So unknowns. How will you write the outputs now?
0.
So 0 plus 0 plus 0 is 0, 0.
0.
Next.
0 1.
This is 0, 1. Okay. Next.
0 1.
Again 0 1.
0, 1. Next.
1 0.
1 0.
1, 0.
0 1.
0,
Next.
1
1
0.
1, 0,
1 0.
1 0.
1, 0,
1 1.
1,
1
1. No, min terms. Carry is equal to sum of min terms.
3
3 5 6 7.
7.
3, 5, 6, 7. Next sum.
1 2 4 7.
1, 2, 4, 7. You do the K map and you'll get the answer for sum as
Sum as
A
A XOR
XOR
B XOR
A XOR B XOR C in.
C.
for carry.
AB plus BC in plus C in A.
C in A. So these are the Boolean expressions which you'll get after doing the K map. Next, suppose if you want to draw this particular diagram by using basic gates, how should I draw? Only basic gates I want. How will you expand A XOR B XOR C in?
A XOR B is A B bar plus A bar B. Do that with XOR C.
So without doing directly, I'm writing. It will be like this: AB, BC, CA, and normal ABC. Generally, if you want to do this one individually, you need to expand. Like you take A XOR B. A XOR B is nothing but A B bar plus A bar
Plus
B.
A bar
Plus A bar
Overall, this should be
XOR
XORed with C in.
C.
So how should I expand this one now?
A B bar plus B A bar B whole bar into C in plus A B bar plus A bar B into C bar C in bar.
So this is A B bar
C
plus
in
A
bar
bar B.
plus A bar B plus A bar B whole bar into
So
C in.
like this, you need to write and you need to elaborate this one so that finally you'll get this answer. Or else let me do. So this is A B bar C in
C
bar.
bar in.
Plus A bar B C in bar.
Now how should I expand this one? A plus B whole bar. Which law?
Morgan's law.
So De Morgan's law. Expand. A plus B whole bar means
A
A
bar
bar dot B bar. A bar dot B bar. Correct?
Yes sir.
Next, how should I elaborate A dot B bar whole bar?
A
This is
bar
A
into
bar
B.
plus B. A dot B whole bar is A bar plus B bar. Next here this will be A
A
plus B
plus B.
bar. Overall multiplied with C. Try to multiply them internally. If you multiply them internally, A into A bar is 0 or 1.
1,
0
A into A bar is 0. A into A bar plus A bar into B bar plus BA
B
plus
A
BB
plus
bar
B bar
whole multiplied with C in.
C in.
So this will go away,
B
this
into
will go away.
0
Try to multiply them internally. So you'll get A bar, B bar, C in,
plus
A,
A B
C.
C.
This is the final answer which I wrote. Sum and carry. So based upon this one, try to draw the logic diagram. Now your question is how to implement this one by using half adders. So full adder implementation by using two half adders and one OR gate. So you know the diagram of half adder. How many gates will be there for half adder? XOR and
XOR and
XOR
AND.
and AND.
XOR gate and AND gate. So your two inputs are nothing but A and B. So 2 times you try to draw the half adder diagram. Now the output of first one will be given as the input for the second XOR gate, and externally you need to apply the third input, which is Cin. This is Cin. Now the diagram format should look similarly, so I'm connecting these two signals once again. So this is one output, and here I'm getting one, here I'm getting one output. So here the output is nothing but sum. So we are left with what?
Carry.
Sum is over.
Carry.
Carry. So for carry, one externally we need to apply one OR gate. So take one OR gate, and output of this AND gate should be given as the input now. So that output will be carry. So this is how we will implement full adder by using two half adders and one OR gate. If you are getting confused with this, better try to write the equivalence. What will be the output at this point?
A XOR B.
XOR B.
It is A XOR B. Here
AB.
AB.
AB. Here
A XOR B XOR C.
A XOR B
C.
XOR C.
We got the answer for sum. Now here what is the output?
A B.
A XOR B. C.
Okay.
Dot C.
Dot C. Now what is the output for this line? It is A dot B.
A dot
From
B.
here if you observe, try to add them. Try to add A
A
XOR B
XOR B dot Cn plus
plus
AB.
S A B.
try to expand it
A B
and
bar
minimize.
Cn plus A bar B Cn plus
A B
AB.
bar plus A bar B into
C.
Cin. Overall it should be multiplied with AB. Finally you try to
C.
minimize it. You'll get the answer as the one which we got earlier, AB B C in A. So mostly they will look for this particular diagram if this question is asked. Full adder by using two half adders and one OR gate, and Verilog code is also important. Okay, so by means of concept called as instantiation, we can write the Verilog code, or else by simply in terms of gate level modeling also we can write. So assign some output wires, and based upon that you try to fill this.
Yes.
Next, any more?
De-Multiplexer, sir.
You want De-Multiplexer? Actually, De-Multiplexer is not there for us. Okay, if you want, we shall do. So still any other doubts in adders, subtractors?
No, sir.
So multiplexes is covered. What about priority encoder? What is priority encoder?
You explain that also, sir.
And code converters.
Those are clear, sir.
So you'll get one from code conversion also from unit 2. So mostly I've kept everything in priority encoders also. If interested, you better go through this one, like decimal to BCD priority encoders and all this stuff. And comparator is also one of the important question. Mostly in order to waste your time, they will give you 2-bit or 4-bit. So 4-bit only Rishika will do, I think.
Sir, I'll also explain it, sir.
Okay, better explain tomorrow once again so that this recording others will use for the sake of revision at least.
Done, sir.
And Samira, are you there? I want someone who can revise the implementation of all the basic gates, I mean all the logic diagrams by using only NAND or NOR.